All right, so for number one, we're given a sequence. We're supposed to figure out the pattern to find the next three terms, the general term of the sequence, and the 10th term of the sequence. So this type of question almost always is going to come down to our two big types of sequences in series, right? The arithmetic, which is when our pattern is adding or subtracting the same thing, and geometric, which is when we are multiplying or dividing by the same thing. So for both of these, the easy part in terms of the points should be to recognize the pattern. So the first one, it looks like we are adding 7 every time, right? So 9 plus 7 is 16, 16 plus 7 is 23, and we can keep going by adding 7 to find the next, that is not plus 7, to find the next three terms. So that, I think, is only worth a point or two, how I used to do this one for the rubric, the scoring. So the next thing is obviously finding the 10th. We're at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We could do that until we got the 10th, even if we couldn't figure out the general term. But the general term is the rule that lets us get any one of these. And for arithmetic, this is going to be given to you on the test. As long as you recognize that we're adding the same thing each time we're doing an arithmetic, you are looking at this formula. And the only pieces of this formula that we want to replace are our A1 and our D. We want to leave the n's alone because this is basically giving somebody a rule that if you input this n, this should be the answer. So we already have the A in here. The only thing we need to do is replace our A1 with our first term. We're going to leave the n minus 1 there because that's what people are going to plug into my formula. And I'm going to replace D with our common difference, 7. Now remember, you can find your common difference by taking any term and subtracting the term before it. So 16 minus 9, 9 minus 2, 23 minus 16. All of these should give us our common difference of 7. Then we could either use this to find our 10th term, or as I said, we could just keep adding 7. Since I want to check my work, I'm going to go ahead and use the calculator to check my work and get me the 10th term at the same time. So remember, the function, the sequence notation is very similar to our function notation. We have some input and it gives us an output. So we can go ahead and use the table feature if we want to write this in. So I'm going to go ahead and tell this, Zoom is terrible. Oops, that's not what I wanted. I wanted it to autofocus. Autofocus? All right, that looks a little more clear. So I'm going to type this in with, instead of an N, I'm going to do an X, but it does the exact same thing. It allows people to plug and chug into this. So X minus 1 times 7. All right, so now this looks exactly like what I have here. The only difference is I'm using X for my input variable instead of N. Starting at 1 and stepping by 1 is perfect. That's exactly what a sequence does. And we can see our pattern, 2, 9, 16, 23, and we can scroll all the way down to number 10. This is going to be 65. So not only did I get to check that my general term was correct by seeing that it gave me out all those terms from before, but I also was able to then get my 10th term. Cool. So that's the first one. Second one does have a typo. This should be 203 or 208. I can't remember what the typo is. Because it looks like our pattern here, 1664 divided by 2 is 832, divided by 2 gives me 416, divided by 2 should have been a 208, but I had a typo there. So we can follow this pattern, dividing by 2, to find the next three terms. So I'm just going to take my calculator, divide by 2 again, divide by 2 again, and one more time, 104, 52, and 26. And if I recognize that we're in geometric land, I know the formula for geometric because it's going to be given on the test. A1 times r to the n minus 1. Again, we're going to replace the A1, we're going to replace the r, and we're going to leave the n's there so that way people have a rule to get the rest of our thing from. So This is one where I've seen a lot of mistakes. Our A1, that's 1664. Students have trouble with the dividing by 2 because our R is our common ratio. It's what we multiplied by. So dividing by a number is the same thing as multiplying by 1 over that number, by multiplying by its reciprocal. So our R here is 1/2 to the n minus 1. Another way we can see that, it is important, by the way, that you have parentheses here. Some people have been forgetting those. Because if it's not there, the n minus 1 looks like it's only happening to the 1 and not the 2. The other way to do this is like we did for the common difference. You can find your common ratio by taking any term and dividing by the term before it. So 832 divided by 1664, or 416 divided by 832, or my corrected 208 divided by 416. These should all give you out the exact same value because we're talking about a common ratio. So again, I could plug in. Another way to check my work here, if I wanted to, I don't like the idea of the table and the function notation and the sequence notation are just too different for me to wrap my head around. You can also use the expression evaluator, and you can tell it what the expression that is that you want. Again, parentheses will really matter here. So it's maybe worth just doing this 3 more times to double check, ooh, I have an extra 6, that what you typed in here is correct. And this is all, there isn't an n, unfortunately, so you're still going to have to choose some variable other than n. So you might as well choose x. And at that point, you're really not that far different. And it's going to tell you what x do you want to plug in. You're really not that far different from what you would see in the table. So 13/4. You can also, of course, just type this in. If you have a different calculator, just be aware that whatever you're raising to as a power, let me go grab a calculator. If you have a different calculator, it doesn't do this thing where you can actually see what's in the power. What you're going to want to do is if you type in 1664, 1/2 in parentheses, to the, you need to put 10 minus 1 in parentheses, or just make it 9. If you don't, see, I still get this, which is also 13/4. But if I don't, if I do the same thing, I'll bring it back and I'll do it without parentheses. If I do it without parentheses, what's going to happen is my calculator is going to deal with this exponent first and then just subtract 1. So I'm going to get a very different value. So the order really matters. Put parentheses around things, especially if you don't have a calculator where you can make something look exactly like your problem.